Good afternoon, students. So up to now we discussed about the motion, right? So in that we have discussed the distance, displacement, speed, velocity, acceleration. So types of acceleration, right? So here one more concept is there. So that one is relative velocity. So in the initial class only we discussed motion and rest. Both are relative terms. So here we know velocity, that is rate of change of displacement we call as velocity. So what is nothing but relative velocity. So what is relative velocity? So relative velocity is the velocity of an object with respect to another object, right? So if we define the relative velocity, it is defined as velocity of an object with respect to another object, right? So we are going to measure the velocity of a particular object with respect to the another object. So this object, that is the second object, either it may be at rest or it may be in motion. That means this object, its velocity may be 0 or it has some velocity. That means this object is also moving, right? So when two objects are moving, so we can find the velocity of one object with respect to the another object. So that kind of velocity we call as relative velocity, right? So the second object may be either rest or either it is in motion, right? So now we need to derive the relation, that is mathematical form, right? So consider two objects or two vehicles, right? So this one is the object A or vehicle A moving with a velocity VA, right? So somewhere here the another object, so it is moving with a, here it is A, here it is B, right? So this is the origin point of these two objects moving with two different velocities. So object is moving with velocity VA, object B is moving velocity with B, that is VB, right? So up to now we discussed only the velocity of the object VA, that is due to the origin, right? So from here how much velocity the object is moving, right? So what is relative velocity means we are going to find the velocity of the object A with respect to the object B, right? So we are not comparing with the origin. We are measuring the velocity of this object with respect to the second object, or we are going to measure the velocity of B with respect to A. That means we are comparing the velocity of one object with respect to the another object, right? So in both the cases we taken that starts from the origin, right? So the initial displacement of the object up to here we taken this one as xa of 0, right? So initial when time t is equals to 0, the object is at a distance xa, right? So in the same way at t is equals to 0, the object b is at a distance xb of 0, right? So as these two objects having the velocity after some time t, right? So after time t, either it may be 10 seconds, 20 seconds. So it travels some time t, then these two objects cover some distance, right? So after some time t, the object or the vehicle is here moving with the velocity va, right? So after the same time, this object B is also moving with the velocity Vb, right? So at this time, the position of the object is xa of t, right? So here also we taken the position of object B, that is xb of t, right? So that is the distance here to here, right? So xa minus xa of 0, that means this xa of t is at a distance from the origin to here, the distance is xa of t. In the same way here the distance xb of t is from the origin, that is xb of t, right? So this one is the first step, right? So after some time t, these two objects is traveled and it covers some distance, right? So here to here it covers the distance xb of t. So how much distance it is covered is xb of t minus xo of 0, right? So if we difference this value by this one, we get this distance, and also here this distance is xa of t, right? So if we subtract this distance minus this, we get this distance. It is traveled in a time t, right? Now starts to write the equation, right? So velocity of VA, that is equals to change in displacement to the time taken, right? So how much time it is traveled here? So this much of the distance it covered. So we need this distance, means we need to subtract XA of t minus XO of 0, that is XA of 0, right? So XA of t minus XA of 0 divided by t, right? So that gives the displacement here, right? So next, this one is the final point, this one is the initial point. So XA of t minus, so here XA of 0, right? So 0 indicates what? When t is equals to 0, here t represents what? Well, after certain time t, right? So similarly for VB, right? So VB is equals to XB of t minus XB of 0 t. So calling this one as equation 1, equation 2, right? Now subtract equation 2 by equation 1. So we are going to subtract these two equations. So we get in the LHS VA minus VB, right? That is equals to, in the RHS also, XA of t minus XA of 0 by t minus, so this value XB of t minus XB of 0 whole divided by t, right? So now if you observe these two relations, so here in the denominator we have the same term, that is t, right? So we can take common t. So now if we shift this to LHS, we get VA minus VB into t, right? That is equals to, now rearranging these terms, XA of t minus XA of 0, so minus into plus, minus XB of t minus into minus plus XB of 0, right? Now, so keeping in the LHS as is, VA minus VB into t, that is equals to, so XA of t minus XB of t. So writing these two in one side, right? Next, in remaining these two terms, we taken minus as common, right? So if you take minus as common, we get XA of 0 minus XB of 0, right? So we are rearranging this in this form, right? So we need the displacement because we are finding the relative velocity of the object A with respect to object B, right? So here XA, after some time the object is somewhere here, the object B is here, right? So this is XA of t. We need relative displacement between these two objects, so that displacement is given by XA of t minus XB of t, right? So we need this displacement. If we find this displacement, then we get the relative velocity, right? So we know the velocity is again by displacement by time, right? So velocity is equals to displacement by time, right? So by using this relation, first we find the velocity of A. So the displacement is XA minus XA of 0. So similarly, XB of t minus XB of 0. So that gives what? VA and VB, right? So in the similar wise, we need the relative velocity of the object A with respect to object B. So we need to find the displacement, right? So this displacement gives what? The relative displacement between the object A and object B, right? So if you find the relative displacement, right? So we need to find the relative displacement between these two objects. So that one is given by XAB. That means the displacement of A with respect to B, right? So XAB is equals to, right? So this displacement minus this displacement, right? So for that it becomes XA of t minus XB of t minus its initial displacement XA of 0 minus XB of 0, right? So calling this one as equation 3 here, right? So here this one as equation 4, right? So by observing these two relations, equation 4 and equation 3, so this term in the RHS and also this term in the RHS both are the same, right? So we just replacing here VA minus VB into T, that is equals to XAB. So that is from equation 4, right? So from this equation we are just replacing the values. So in the equation 3 and equation 4, the right hand side are same, then automatically the left hand side becomes equals to one another, right? So this equation 3 becomes VA minus VB into T, that is equals to XAB, right? So that is from the equation 4. So here we need the relative velocity, right? So relative velocity is equals to relative displacement divided by time taken, right? So here our main aim is to find the relative velocity, right? So the relative velocity is equals to relative displacement by time taken. So relative displacement is defined by XAB, right? So here we written relative displacement is given by XAB, right? So relative velocity, that is VAB, is equals to relative displacement is what? XAB divided by T. So we know this we taken as equation 5, right? So from equation 5, VAB is equals to, in place of XAB we can substitute VA minus VB into T all divided by T, right? So here T and here T get cancelled. So the final we get the relative velocity VAB is equals to VA minus VB. So this one is the final relation, very important while solving the problems, right? So don't confuse the relative velocity of the object A with respect to B. If both are moving in a same direction, then VA minus VB, right? So this one is the first relation. So VAB is the relative velocity of A with respect to B, right? So WRT is with respect to B, right? So VAB represents what? The relative velocity, that is velocity of the particle A or object A with respect to B, right? So that one is given by the relative velocity A with respect to B. That means the velocity of the object A with respect to object B is given by VAB, that is equals to VA minus VB, right? So if the object is moving some 10 meter per second in the same direction, the object is also moving with some 5 meter per second, right? Then the relative velocity of the A with respect to B, we can find VAB is equals to 10 minus 5, that is equals to 5 meter per second. So, but the actual velocity of the object A is how much? 10 meter per second. But relative velocity with respect to B, comparing the velocity of the A with respect to B is how much? That is 5 meter per second, right? So this is a very important relation when both objects are moving in a same direction. In the same direction means VA minus VB. right? So next, if we need to find the relative velocity of B with respect to A, right? So by using this relation, VAB is equals to VA minus VB, right? So in the right hand side, if we take a minus as common, right? So here VA becomes minus VA. So here minus becomes plus VB, right? So we are going to take a minus in the right hand side of the relative velocity of A with respect to B, right? So that is equals to minus of VB minus VA. So we can write this one as like this, right? So plus VB minus VA, right? So we can write this one as minus VB, right? That means VBA is what? Relative velocity of B with respect to A, right? So the relative velocity of the B with respect to A is minus VAB, right? So this VAB is equals to VBA is equals to minus VAB, right? So this can be written as VB minus VA, right? So if we take on the same example, the object A is moving with respect to 10 meter per second, object B is moving with 5 meter per second. So the relative velocity of B with respect to A, that is equals to 5 minus 10, that is minus 5 meter per second square. So but here we get plus 5 meter per second, right? So that means A is moving faster than B, right? So if VAB is positive, this value is positive, that means VA is greater than VB, right? So VAB final value, we will get the positive value. So here we are getting the positive value. So that means this indicates what? VA is moving fast with respect to B, right? So if VAB is negative, right? So this value is negative, then VA is less than VB. So that means the object is somewhere here, the object B is moving forward, right? So VB is moving faster than VA, right? So if we write the displacement time graph, right? So if the relative velocity VAB is, so this is for the positive case, then VA is greater than VB. So if it is negative, then VA is less than VB, right? So one more case, if VAB is 0, that means the relative velocity of these two objects is 0, that means VA is equals to VB, right? That means these two are moving in a same velocity. So if the object A is moving some 5 meter per second, so same wise the object is moving in 5 meter per second. So if we substitute these values in VAB or VBA, so here we get 5 minus 5, 0. So here also if we substitute 5 minus 5, we get 0, right? So the relative velocity is 0, that means VA or VB is equals to VA or VA is equals to VB, right? So for this case, if we plot the displacement time graph, then we get a curve like this. So that is what when VAB is equals to 0, that is velocity A is equals to velocity B. So if the object is moving, so certain displacement from here, so in the same way the displacement remains constant, right? So both are moving with the same speed, but it has an initial constant distance, right? Because initially we have a displacement between these two objects some 5 meters. So each and every time these two objects will moving with the same displacement of 5 meters. Hence we are getting the graph like this, right? So this one is VA and VB, right? So in second case, for the displacement x and t, right? So for this case, VA is greater than VB, then these two graphs will meet at somewhere like this. So this is when VA is greater than VB, right? So these two objects will meet after certain time t, right? So by doing problems, we can find this time, right? So this is about the relative velocity. If the two objects moving in a same direction, then the relation we have VAB is equals to VA minus VB. So by this we completed the first chapter, motion in a straight line, right? So now we will solve few problems on this chapter. Right, take down first problem. A car is moving in a car is moving along a straight line or along a straight path with speed 126 kilometer per hour to brought to stop within within a distance of 200 meter. What is the retardation what is the retardation of car, and how long does it take for car to stop, right? So to solve the problem, first we need to understand the concept in the problem. So what they are going to say and what we are going to find and what are the given data to solve or to find the unknown variables, right? So first we need to understand the concept of the question, right? So they are saying a car is moving along a straight path, right? So if we consider this one as a straight path, so one car is moving, right? Moving in a straight path. So they given with a speed. So that means it has some velocity v is equals to 126 kilometer per hour. The car is moving with a velocity or moving with a speed 126 kilometer hour. Next, to brought to stop within a distance of 200 meter. That means they are saying after it travel 200 meter, so this car going to rest. That means the car is going to stop. So how much distance or displacement it covers? So it covers 200 meters. So when it stops means, so given the initial velocity u, then we know the final velocity is 0 because the car is at rest. After it covers 200 meters, then car is at rest, right? So this is the given data, right? So next, what we are going to find is what is the retardation of the car. So retardation is nothing but the acceleration, and how long does it take for the car to stop. That means here we are going to find the acceleration of the car and the time taken to stop the car or the time taken to cover this 200 meters, right? So this is about the question. So in the exam now, don't write all these diagrams and like this, right? So just for 5 marks, we need to mention the data, right? So first we need to write given. What they are given: initial velocity, that is 126 kilometer per hour. So the SI unit of velocity is meter per second. We need to convert this kilometer per hour into meter per second. So that is 126 into 1000 divided by 60 into 60, right? So 60 minutes, 60 seconds. So 10 get cancelled, 10 get cancelled, right? So 2 5s are 10, 2 3s are 6. So every time if they given in kilometer per hour, so this value is equals to 5 divided by 18 meter per second, right? So every time don't need to write the 1000 divided by 3600, right? So directly we can substitute here 126 into 5 divided by 18 meter per second, right? So here, how much we get here? 6 are 12, 15 is 6, 9 are 18. So 9 7s are 63, that is 35 meter per second. So the car is moving with a velocity 35 meter per second, right? So this one is the given data. So one more data they given, distance, that is we taken x is equals to 200 meter. They given the distance, right? So one more, they given the word how long does it take the car to stop. That means they didn't mention anywhere in the problem about the final velocity. We have to know that the final velocity is 0 because the car is at rest after it covers the distance 200 meter, right? So next, to find what we are going to find in this question, right? So that is the retardation. So we need to find the acceleration. Retardation is nothing but the acceleration. That is the negative acceleration. If we get the answer in negative, then only the problem is solved is correct. So if we get the positive, then we did the mistake, right? So how long does it take? How long is nothing but time. So we need to find the time, right? So next, we have three equations of motion. So we have the three variables u, x and v, right? So from that first we need to find the acceleration, right? We have the three relation v is equals to u plus at, x is equals to ut plus half at square, right? So v square minus u square is equals to 2ax, right? So here, if you observe here in the first equation, we know v, we know u, but we don't know a and t. We are going to calculate. So if we substitute these input data in this equation, so it is not possible to find any one of the term, right? So similarly, if we put, we know x, we know u, but we don't know t, and also we don't know a, right? So first we need to check in which equation if we put the data, we get the solution for the question, right? So here we know v, we know u, and we know x also. From this we can find a, right? So by using the third relation, v square minus u square, that is equals to 2ax. So what about v square? So v value is 0, so 0 square is again 0. So u square is 35 square, right? That is equals to 2 into acceleration is unknown and x is 200, right? So here we need to find acceleration, right? So a is equals to minus 35 into 35 divided by 2 into 200, right? So we need to simplify this minus value. So minus value is nothing but the retardation. That means negative acceleration, right? So unit is very important. If you left the unit, then you 1 marks will be deducted. So there is no use of solving up to here, right? So this one is the first one. Next, we need to find the time taken to stop the car, right? So already we have the relation, three relations. So in any one of the relation you substitute, then you get the time. So by using simpler equation, v is equals to u plus at. So v is 0, again u is 35. So plus acceleration is how much? Minus 3.06 into t. Right? So here plus into minus, minus, if it shifts to LHS, it becomes 3.06 t, that is equals to 35, right? So t is equals to 35 divided by 3.06. So if we take a round value, that is 3, So 11.67 seconds. So approximately we get this value. By taken round off here 3.06, we taken approximately. So don't do in the examination. We have the availability of calculator in the exam now, right? So 35 divided by 3.06. So around you get 11.8 or 11.9 second, right? So this one is a simple problem. So they given we have the 5 variables, right? So u, v, acceleration, displacement, time. So we have the 5 variables. So out of these 5 variables, they mention any 3, right? So in the given data, we need to find the unknown. So if they given these 3, so from that data we can find u and t. Otherwise, if they given these 3 variables, we can find v and u. Again by the 3 equations of motion, right? So 5 marks, we need to write all the steps with clarity. So for writing the formulas, we getting 1 mark. For writing the unit, we are getting 1 mark. So without suitable formula, if you simplify the problems, you will get 0 marks. Right. Next, second question. A stone is dropped. A stone is dropped from top of a tower 100 meter, from a top of a tower 100 meter height. Right. At the same instant, another stone is dropped. Another stone is thrown vertically upward from the base of a tower, from the base of the tower with velocity of 25 meter per second, with velocity of 25 meter per second. When and where will the two stones meet? Then given g is equals to 10 meter per second square, right? So this is the question. So what you understand in this question? So a stone is dropped from a top of a tower 100 meter, right? So this one is the ground, right? So up to here some tower is there, right? So calling this one as tower, right? So this tower height is they given how much? That is 100 meters. So height of the tower is 100 meters, right? So every time while solving the problems, for better understanding, either we are converting this in the form of diagrammatically, or we can convert this in the form of the equation. Then only we can easily simplify the problems, right? So first we take a ground and we have a tower that is of the height 100 meters. That means they given h, right? 100 meters. Next, at same instant, so that is from the height of the tower, what they are doing? A stone is dropped, right? So from this height, one stone is dropped, right? Next, in the same instant, another stone is thrown vertically upward, right? So in the same time, while dropping this stone, in the same time another stone is thrown vertically upward, right? So it's with velocity u is equals to 25 meter per second. So without velocity, this stone will not move in the upward direction, right? So for that, they are giving the velocity, right? So next, we need to find these two stones will meet somewhere here. We don't know where these two are meeting. We need to find at what distance these two are meeting and at what time these two are meeting, right? So we need, here they given only the data is 100 meter and 25, but these two are the separate cases, right? So one is case 1. In case 1, the stone is dropping down, that is vertical motion, right? So in the case 2, stone is throwing vertically upward. So in these two cases, the common term is what? Height of the tower, right? So taken x as some distance, that is from the top of the tower, right? So from the top of the tower, we are considering some x distance. So we don't know how much distance these two, in what distance these two stones are meeting. So that distance we are taken as x, right? So if the stone travel x distance and the second stone, this one is the first stone and this one is the second stone. So this stone will travel up to here. How much distance? So the total height is what? 100 meter. So out of this 100 meter, x distance is traveled by the first stone. So remaining distance, we get 100 minus x, right? So the stone is dropping, that means its initial velocity is 0, right? So by using the distance relation for case 1, either we can use, here we don't know the velocity, final velocity of this stone, and we don't know the final velocity of this stone, right? So the better relation here is x is equals to ut plus half gt square, right? So we know what the relation for upward motion and what's the relation for the downward motion, right? So in the first case, that is the case 1 is for the stone which is dropping vertically downward, right? So here h is equals to ut plus half gt square. This is for the downward motion. For downward motion, g is always positive. Don't forget that one, right? So h, how much distance it is covered? X distance, right? So x is equals to, initial velocity is what? Initial velocity of the first stone is 0, right? So 0 into t, again we get 0 plus 1 by 2, they given g. How much? That is 10 into t square, right? So from this we can write x is equals to 5 t square, right? Calling this one as equation 1, right? So again, from the second case, by using the same relation. So here in the second case, what happens? Upward motion. So motion of the stone in vertically upward direction. So the equation of motion, again we have h is equals to ut minus half gt square, because vertically upward motion we taken acceleration as negative. That's why we have taken minus here. So how much distance is covered by the second stone? How much distance? That is 100 minus x. So this much distance is covered by the second stone, right? So that is equals to, they given its initial velocity u. How much? That is 25 into t minus 1 by 2. The g is constant, that is 10 t square, right? So here 100 minus x, that is equals to 25t. So again 10 divided by 2 minus 5t square, right? Calling this one as equation 2, or so here we know the value of x, right? So substitute the value of x in the second equation. So that is 100 minus, in place of x, that is 5t square, that is equals to 25t minus 5t square, right? So now observe, In the LHS also minus pi t square. In the RHS also minus pi t square. So these two values get cancelled. Right? So here we get 100 is equals to 25 t. Then t is equals to 100 by 25. That is equals to 4 seconds. Right? When and where? So when t is equals to 4 seconds, these two stones are meeting. Right? So now where they are meeting, just substitute this 4 second in first equation. Right? So x is equals to 5t square, right? So 5 into t is what? 4 seconds. That is 4 square, right? So 5 into 16, that is 80 meter, right? So where they are going to meet, that is 80 meter from the top of the tower, right? So we need to mention this one. X is equals to 80 meter from the top of the tower, right? Or so x is equals to 20 meter from the ground. So if we add these two, we get the total height of the tower, right? So understand this one. So by this way we are going to simplify. So this one is the next level problem, right? So when and where, here we consider x as the distance that is from the top of the tower, because for our reference they given tower as a reference, so always we consider this value, that is x is equals to 80 meter from the top of the tower, right? So remaining problems we will continue in our next class, right? Thank you.